Why does time only move forward? I mean, really, why is yesterday always behind us and tomorrow always ahead? It's one of those questions that's so big, so fundamental, we barely even stop to think about it. But the answer, well, it takes us right to the very edge of reality itself, from the weirdness of the quantum world to the inner workings of our own mind.
Think about it. It seems totally obvious, right? Of course you can remember what you had for breakfast, but you have no clue what you'll have for dinner tomorrow. But that simple, everyday fact, it's not just common sense. It's one of the biggest clues we have to solving one of the deepest puzzles in all of physics.
Okay, let's really dive into this, because here's the paradox that's at the heart of everything. Most of the fundamental laws of physics, the rules that run the universe from planets down to particles, they couldn't care less which way time is flowing. You could play a video of a planet orbiting a star forwards or backwards, and it would look totally normal. But in our world, in our reality, time is a one-way street. Eggs splatter, but we never ever see the mess magically reassemble itself back into a perfect egg. This stubborn forward march is what we call the arrow of time. So where does it actually come from?
So where do we look for our first clue? Well, not where you'd expect. Not with clocks or looking at the stars, but in the incredibly strange and fascinating world of quantum mechanics. We're going to look at a famous experiment that has been blowing scientists' minds for over 100 years. So, imagine you're firing tiny particles, say electrons, one by one at a wall with two little slits in it. Now, if you don't watch to see which slit they go through, you get this beautiful, strange wave pattern on the detector screen behind it. And that pattern can only happen if each particle acted like a wave, going through both slits at the very same time and interfering with itself. It's not a bullet, it's a cloud of possibilities.
This is where things get really weird. What if we just peek? What if we put a tiny little detector right at the slits to see which path the particle actually takes? It's just a simple act of looking, of gathering information. Surely that can't change the outcome, can it?
Oh, it absolutely can. The moment we measure, the moment we look, that whole wave thing is just gone. The interference pattern vanishes completely, and instead we just get two simple bands on the screen, exactly like you'd expect if you were just firing tiny bullets. It's like that cloud of possibilities was forced to make a choice. The simple act of observation fundamentally changed what happened. So, what on earth is this measurement? What is this act of observation that seems to reach in and change reality itself? Well, there are two main ideas here, and they get right to the heart of our question about time.
So, the traditional way of thinking about this is something called wave function collapse. The idea is that when a measurement happens, that whole wave of possibilities just, poof, instantly collapses into one single definite reality. And here's the key part. This collapse is a one-way street. It's seen as fundamentally, absolutely irreversible. You can't uncollapse the wave.
But there's a more modern explanation, and it's called decoherence. This idea says there's no mysterious collapse at all. Instead, when our little particle interacts with its environment, and that could be just bumping into a single air molecule, they become linked up or entangled. Information about the particle state leaks out into the wider world, and it's this leakage of information that washes out the quantum weirdness.
And this, right here, is the key difference. Wave function collapse says you can't go backwards, period. It's a law of nature. Decoherence is a bit more subtle. It says, well, in theory, you could reverse the process, but you'd have to track down every single atom and photon that the particle interacted with. In practice, that's impossible. It's like trying to unscramble an egg. So it's practically irreversible, even if not fundamentally so.
And here is the grand connection, the aha moment. This irreversible spreading of information out into the environment is, in the language of physics, an increase in entropy. You can just think of entropy as a fancy word for disorder, or how spread out and messy a system is. By smearing information all over the environment, decoherence makes the whole universe a little bit messier. The arrow of quantum measurement points in the exact same direction as the arrow of time we see in thermodynamics.
Okay, so we've gone from a single tiny particle to the entire universe's tendency towards disorder. Now, let's take that same idea and scale it all the way up to the most complex, most amazing information processor we know of, the human brain.
You know, this isn't a new question. Decades ago, one of the founders of quantum mechanics, Erwin Schrödinger, asked this very thing. How does life, which is this incredible engine of order, creating complex things out of chaos, how does that fit into a universe whose laws demand that chaos should always, always increase?
And our brains are a pretty stunning answer. They're a bit like something out of a famous old thought experiment called Maxwell's demon.
a little being that could create order out of chaos. To form a single memory, your brain has to burn a huge amount of energy. In doing so, it creates this tiny, perfect pocket of order, information, inside your head. But the price it pays is releasing a whole lot more heat and disorder out into your surroundings. Your brain literally forges the order of your memories by making the total entropy of the universe go up.
And this brings us right back home. That feeling you have right now of time flowing, of the past being solid and the future being open, that might be the direct experience of this physical process. Remembering the past is the physical act of having stored that information, and that act was irreversible. It cost energy, it increased the universe's total messiness. The psychological arrow of time, the one you feel, is being forged by the thermodynamic arrow of time, right inside your own head.
So let's put all the pieces of the puzzle together: the quantum measurement, the relentless increase of entropy, and the workings of our own brain. How do they all combine to give us a coherent picture of how the arrow of time is literally born moment by moment? One really compelling idea is called the crystallizing block universe. So picture it like this. The future is a vast, undecided ocean of quantum probabilities. It's a blur of everything that could happen. The present, our now, is the very edge of this process. And every single time an interaction happens, anywhere in the universe, it causes decoherence. Information gets recorded, entropy goes up, and a tiny piece of the definite, solid, classical past crystallizes out of that quantum foam of possibility.
And this is the truly profound takeaway here. The arrow of time isn't some mysterious top-down law that's just imposed on the universe. No, it's an emergent property. It's an ongoing process. It is being actively forged right now, everywhere. Every quantum interaction, every chemical reaction, every single thought firing in your brain is another one of these irreversible events that converts an open, possible future into a settled, concrete past, pushing that boundary of now relentlessly forward.
So maybe that's what we're all experiencing. The flow of time isn't something that's just happening to the universe. It is the universe happening. A constant, irreversible cascade of possibilities freezing into a single, concrete history. The past is what's been written, paid for with an increase in entropy. And the future is still unwritten, a sea of pure potential.